Hey folks, welcome back. This is our lecture on visual displays of data. Part 1, the good, the bad, and the ugly. Really, before we even jump into it, I guess, like my discussion of why taking statistics is important, I think it's relevant to talk about why graphing, why being able to understand graphs and to create graphs or displays, visual displays of data, can be such an important skill. So, first off, like descriptive statistics, a visual display of data can really simplify large data sets. Seeing two bars of different heights that might represent 3,000 different yeses and nos, or in the case of an election, right, close to 15, 16 million votes are cast. Right, that's a ton, right? And that's even smaller elections. I think in the national general election on this past one, we were close to 10 times that, right? Almost 160 million votes that functionally come down to yes, no. This guy, right? If we want to really, really simplify it. And so seeing that as simply a bar of one height and a bar of another took a ton of data and distilled it into a very, very small amount of visual information. Also, it can make it really easy to see the patterns, right? If this bar is lower than this bar, and then there's another set of bars where this one's lower than that one, we can look to see and say, well, what are the difference between these pairs of bars? Because it looks like the ones on the right are always higher than the ones on the left. You can see those patterns super easily. So that's really, I guess, practical good reasons for learning graphing and why we want to teach about it in statistics. But I think there's more everyday, outside of this class, reasons for learning visual displays and graphing as well. So graduate school, not all of you want to go to graduate school, but many of you do. And the GRE is one of the major exams that you will have to take to get into graduate school. And no, if you're looking at MCATs or LSATs, I'll tell you they also emphasize graphing. The GRE, in fact, a number of years ago, re-emphasized graphing even more so by de-emphasizing some of the other aspects that were currently in the exam, like geometry and things like that, because graphing is so important for being able to present the information that you have, to put it into a figure, to put it into a table. Now, the other, I guess, really good thing about knowing graphing and knowing how graphs work is that you're less likely to get fooled by all the misleading graphs. And there are a ton of misleading graphs. So your book goes through what it calls the best and worst graphs ever. I think that's a little hyperbole, but I still like the example. So let me show you what your book once called the worst graph ever. This is the cover of the Ithaca Times, right? A magazine that is in the town where Cornell, an Ivy League university, is located. So it's got a simple graph. We see a blue line that shows, as it says, Cornell's university tuition. Looks like it is continuing to go up. We also see an orangey, yellowy line there that looks like it ends up pretty low. It says Cornell's university ranking. So what do we see here? Looks like ranking continues to go down while tuition continues to go up. At least in a quick brush glance, that would not seem to be a good thing. It seems as though Cornell is charging more and more money while they are giving a less and less quality education. But let's look at the graph a little bit more closely, because there are several things in here that are, at the very minimum, misleading and maybe even outright lies. So first of all, look at the scales. If we imagine an x-axis here that was running along the bottom, it looks like x-axis refers to time. Right? So the blue line goes from 1985 to 1999, right? A period of 14 years. The yellowish line goes from 1965 to 1999, a period of 34 years, an additional 20 years longer. Why are they on the same chart? Shouldn't the blue line really be shifted way over and really only correspond to the last portion of that yellow line and not stretch to make it look like 34 years of changing ranking was related to only 14 years of changing tuition? So that's one problem. Another problem is that realistically, these two scales, so what's on the y-axis? In one case, it's tuition, so money, and the other case, it's ranking. The tuition's an interval scale, right? It's like basically a continuous measurement, right? You can break it down. It could be $5, it could be $1,000, it could be $395.62, and every derivation right in between. But ranking is ordinal. Your first, your second, your third, your fourth, your fifth. It's not gapped evenly like an interval scale is. First place could be really damn near as good as second place, but second place could be way better than third place, right? And so the scale points aren't equally gapped. So incompatible scales. How about the starting points? If there's no similar y-axis, and one's ranking and one is tuition, why is tuition above ranking? If I did it the other way, and I put tuition way below ranking, I might make it look like the two lines converged. Instead, it looks like the two lines go apart. There's no reason for this to be the case. It simply makes it look like they're going in dramatically different directions, as tuition is way going up and ranking is way going down. And maybe perhaps the most misleading is that it really implies a reversal of the meaning of ranks to begin with. So think about rankings, right? My life in the last couple of months has been largely about college football, right? And so I look at colleges, I look at these universities, and I think about their individual rankings. I personally always think Georgia is number one. Unfortunately, the AP poll and their stats don't always support that. In this case, we found that Alabama was number one. So number one in the rankings. If you go from number 6 in the rankings, and then you become number 5, and you become number 4, and number 3, and number 2, and number 1, your ranking goes down in number. But it means your quality goes up. And so this graph is suggesting that Cornell's ranking is going down in quality, when really ranking going down in number means it's getting better. So realistically, this graph is saying that although tuition did rise over this period of time, ranking of the university got continually better. Right? If you, in fact, made the two X scales compatible, so you shifted that blue line over, it probably shows you that the most dramatic period of ranking increase happened when the tuition went up. So there was a justification for it all along. So worst graph ever, in large part because of all these ways in which it lies or is at least misleading about the message and the information it contains. So if that's hyperbole, this one most certainly is as well, what your book calls the best graph ever. If this was the best graph ever, then you would look at it right now and instantaneously know everything it had to say. That's, in my opinion, it would be that clear and easy. But the reason why it's referred to as the best graph ever is that once you understand it, it really packs a tremendous amount of information into an easily understandable format. So these are the data on the number of French soldiers that Napoleon brought with him on his ill-fated trip to Moscow. So he invaded Moscow in the early 1800s, 1812 to 1813, while we were dealing with the British in the War of 1812 ourselves. So Napoleon sent these troops across, and you can see when they leave France, this is the beige line. The thickness of the line at any point, even when it becomes black, is going to represent how many troops there are with his army. Okay? The black is the return trip back from Moscow. The beige is the trip there. So you can see at the far left-hand side, we see a big thick line, a big thick bar where 432,000 troops leave France to head towards Moscow. Now at the bottom, you can see a chart of times, December this, December this, December, November, November, November. This is the temperature at these various times of year. And so you can see how cold it was at different points. And what you can basically see is that any time the temperature drops considerably, so at the lowest points, that's also where we see the most dramatic downturns in Napoleon's forces. He begins to lose tens of thousands of soldiers per day to cold and disease. You can even see at one point there around November 28th where a group of soldiers breaks off and then returns home early and meets up with the return journey. So Napoleon leaves with 432,000, returns home later on with a mere 10,000 troops remaining, having lost 420,000 troops. This graphic tells that story, and does so in a reasonably good way for all of the information that it would have to contain. Is it the best graph ever? No. Is it a good graph? Yes. Why? Because it takes a complicated data set and distills it down to some easily presented pieces of visual graphics that allow you to very clearly see these patterns, even if it takes a minute to sort of unpack it and understand the figure. One last example, because I wanted to talk about how you can lie and mislead again with a graph. It's not always that you're doing it with incompatible scales and the kinds of things you'll see in magazines and on Facebook and the sorts of graphs they portray, but it can also be from, let's say, your legislatures. If you're trying to legislate and ask for more money or try to argue against more money for state troopers, you might bring in some data that shows that state troopers, for example, were effective at lowering traffic deaths. That we put more money into state troopers in 1955, and we found that over the period of 1955 to 1956, traffic deaths went down from 325 to 275. So that's the figure on the left. Well, what if somebody disagreed with you and said, well, yes, they did go down. I think it's worth noting the larger scale here and looking at deaths in 51, 52, 53, 54, and then maybe also in 58 and 59. And what we find there is that although these deaths certainly did decline between 55 and 56, that was actually a high point that was unusual. If you look at the surrounding data, so we can see more of the graph, we can actually see that most of the time traffic deaths are around 250 or less. And so this drop really only brought us back down to normal. Was it because of the increase in funding? Was it not? Well, that's the legislature's decision. My point is that you, as the individual making the graph, or as the individual reading and looking at the graph, have to be critical about what data is being presented to you and what data might not be presented to you. Okay? So that's what a famous book once called Lies, Damned Lies, and Statistics. In the next section, we'll talk about some very specific graphs, some scatter plots, line graphs. We'll then move into a discussion of bar graphs and things like that, and then we'll wrap it all up. All right? Cheers.